Hello everyone. In this video we are going to review various topics on the Algebra I Regents that have appeared in prior Regents tests and exams. So we're going to get right to it with linear regression. This is always a question on the exam. All right, it's always a part 2, part 3, around probably part 3 question. So in this question, they are asking what is the linear regression equation for this data set? Round all of the values to the nearest hundredth. They ask for the correlation coefficient, and they ask you to explain what the correlation coefficient suggests in the context of the problem. So be ready for this problem. So we are talking about inputting all of the data set right here, hours spent studying and test scores, into L1 and L2. And the way that is right here, this is your L1 and this is your L2. So when you input your numbers, you have to press stat and then edit, enter, and then you're just going to press 0, 1, and you're going to go along like that, inputting all of the numbers. Just be careful that you don't input an extra, say like 4, there's 3 4s. 2, 3, and then just look at your screen, there should be 3 4s. There's 2 6s. There's 1 7. And then finally there's 1 8. So you should definitely check to see 1, 2, 3. There's 10, right? 10 students. So they do tell you, you don't have to count it, but there's 10. And you see on the screen right here with the calculator, it does say that it's waiting for the 11th number. We did input, if you go up to 8, you did input 10 numbers. Then you jump over to L2 and you go along 35, 40, 46, 65, 67, 70, 82, 88, another 82, and finally a 95. So really important that the numbers match up, right? So I'm just going to go and show you exactly what I'm looking at. You see how the numbers in L1, they're the same amount of numbers in L1 and L2. That's important. So when you're talking about linear regression has to have the same amount of numbers as L1 and L2, in L1 and L2. So now you press stat and go over to calc, and you go to 4. So you could go down to 4, you could just press 4. And then you press enter 5 times, calculate, and you see what I have on my screen. I'll get to what that means. The y equals ax plus b is equivalent to y equals mx plus b, the a being the slope, the rate, and the b is the y-intercept. So it says write the linear regression equation for this data set. So we have to put y equals, and not in highlighter, y equals. It says round all the answers to the nearest hundredth, so that's what we're going to do. Y equals 7.79. And we're going to round that 9 to, we're going to keep that 9 right there because the next numbers are 2. Then you put the x. You have to put that x because remember, this is y equals mx plus b. And it is plus, this is 34.27, and that is the linear regression equation rounded to the nearest hundredth. And just remember, they're talking about a linear regression equation. You're talking about something with an equal sign. must have an equal sign, and you must round it to the nearest hundredth. So you might notice that there is no correlation coefficient on my calculator. So I'm going to open this up just a little bit so you can see the R is missing. Remember, correlation coefficient on the calculator is R. So I'm going to press mode. And in this mode, you see stat diagnostics, it must be on. Mine is off, and it's by, when you reset the calculator, it's just by default, it goes to off. So just remember, if you don't see the correlation coefficient, press mode, go down to stat diagnostics, move it to on, and then press enter. And then you could press down just to prove to yourself that you did turn it on. Now you could go back to stat, go over to calc, press 4 again, go through the list, pressing enter, and there's the R. That's the correlation coefficient. It is 0.98, and that's rounded to the nearest hundredth. So you're going to put that as R. Again, I write in R equals 0.98. All right, and I put down that to remember to turn stat diagnostics on to see the correlation coefficient. That correlation coefficient is R equals 0.98. And when you see that a number, the correlation coefficient that is that close to 1, it suggests a very strong positive correlation between X and Y. You could leave out the word very, so I just explain what the correlation coefficient suggests in the context of the problem. The correlation coefficient suggests a strong positive correlation between X and Y, and that will answer and get you full credit. Just to take a look at what we have here, this is the graphic that we had in the lesson, and we had this graphic here just to help you out a little bit on what to look for. See how 0.98 is very strong positive. If you have a negative 0.98, that's a very strong negative. Anything between negative 0.8 and negative 0.5, or 0.8 and 0.5 and 0.8, that is a moderately positive. I've never seen that, so the only thing they could put is a weak positive or weak negative. So if it's like 0.3 or 0.1, they would say that is a strong negative correlation between X and Y. Or if it's positive, say like a 0.1, that's a correlation coefficient suggests a weak positive correlation between X and Y. And that is it. So just taking a look at number 2, we are going to bring up the calculator again, press stat, and then edit. And then I'm going to clear out by pressing up to L2, press clear, and then enter. Don't press delete. Go up to L1, press clear, and then enter again. So we are going to put these numbers into our list L1. So 32 would be our first number, 38. Just be careful, 42, 48, 46, 49, 51, 52, 30, 42, 47, 50, 32, 36, and let's see how many numbers we have. We have 14 numbers. We're going to go up and see that we have 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 numbers. So here we go. Remember, we have to have the 5-number summary. It's asking for the 5-number summary. You press stat, you go over to calc, and you leave it on one var stats. We're not going to go down to linear regression because we're not getting the equation for a trend line or anything like that in a scatter plot. We want the 5-number summary. So the 5-number summary is here, and you see it. This is min, quartile 1, median, quartile 3, and max. So those are the 5 things that they want, and we are going to write those down. So the min is 30. Quartile 1 is 36. Quartile 2, which is the median. Just want to make sure everybody understands that, is 44. And then quartile 3 is 49, and the max is 52. Now it's asking, what is the interquartile range? The interquartile range is Q3 minus Q1. So it's right there. So Q3 equals 49. Q1 equals 36. So the interquartile range is 13. And that is it. So it says to find or determine the lower and upper outlier boundary. And the lower and upper outlier boundaries are found on the reference sheet for Algebra 1 given to you. So we're just going to take a look at it right now. Notice quadratic on the left-hand side, quadratic equation, standard form, quadratic formula, the equation for the axis of symmetry, the slope formula, the linear equation, slope of slope-intercept, the linear equation, point-slope, interquartile ranges on there, arithmetic sequence, geometric sequence, exponential equations, and there it is. The lower outlier boundary is Q1 minus 1.5 times the IQR, which is the interquartile range, and the upper outlier boundary is not minus, and it's not Q1, it's Q3 plus the 1.5 times the interquartile range. So you just copy it down, and that's exactly what I did. I put it right here. And we are going to go for the lower first. And if you find your 5-number summary, it is all done for you. So Q1 minus 1.5 times the IQR, which is the interquartile range. So Q1 is 36. So 36 minus 1.5 times the IQR, which we already figured out, which is 13. Now you grab your calculator and you clear everything out, go to the main page, press 36 times minus 1.5 times 13. And it is 16.5. Right? I'll get to exactly what these things mean, but now the upper outlier boundary is Q3 plus the 1.5 times IQR. So we have our Q3 already, it's 49, plus the 1.5, and we have the IQR, which is 13. We grab the calculator one more time. 49 plus 1.5 times 13. And we press enter and you get 68.5. So what we have here is we're looking to see if a number in the data set is lower than 16.5. If it is, it's an outlier. If it's higher, greater than 68.5, then it's an outlier on that side. So let's look at 16.5. If there's an outlier, the min is 30, so there is no lower outlier. Upper, the max is 52, so there is no number that is that is greater than 68.5. So there are no outliers. In this data set. And even though they didn't ask you if there were outliers based on the upper and lower boundaries, the lower and upper outlier boundary, they could, right? Because that's what this is used for, to actually say, you know, like when we looked at a data set and we just asked you, are there any outliers? And then you'd say, oh yes, there's an outlier. There's a number that does not belong. So we could just see exactly that is an outlier. Well, we don't have to now worry about like proving or not, like proving if it's an outlier. This actually, we're not guessing that these are outliers. We're proving that they're outliers using these formulas, right? If they want you to use them, right? If they want you to use them, they'll always tell you. Just remember those are on the reference sheet. So just copy them down, put the numbers into your calculator, get the 5-number summary, and then you figure out the IQR. And that's it. All right. And now we're going to make a box plot. So the only thing that we need is the 5-number summary. So you see how it goes from 30 to 52? I'm just going to put numbers that actually go from 30 to 52. And I think I'm going to go by 2s. Because it's not a wide, like a tremendous range that I can't cover it. And you see exactly what I'm doing. This is 48 already. This is 50. This is 52. I'm going to go to 54. And that's it. And I covered all of what I needed. So I'm going to look right now. The min is 30. So I'm going to draw a straight line at 30. The Q1 is 36, so I'm going to draw a straight line at 36, above 36. The median is 44, so I'm going to draw another straight line right here. And the quartile 3 is 49. 49 is directly right in the middle. That's the beauty about going by 2s. You don't have to guess where they are. And then the max is 52. And that's it. Okay, so now that I have all of the lines down, I am just going to go and connect quartile 1, which is right there, to the median, to quartile 3, quartile 1, to the median, to quartile 3. Then I'm going to connect from quartile 1 to the min, just like that, and from quartile 3 to the max. And there is my box plot. Now they could ask you some questions that they always seem to ask. Just remember, each one of these, from the min out to Q1, this is Q1, this is the min, this is Q2, this is Q3, out to the max, right here. Each one is 25%. So if they ask you what percent of the data is between quartile 1 and quartile 3, you say 50% of the data is between quartile 1 and quartile 3. If they ask you what percentage of the data is in between max and Q3, it's 25%. And that is finished. So it says solve for the equations algebraically, so that's kind of like what you have to do, for all values of x and y. So the first thing that I am going to do here is to get both of these equal to y, because then if you get both of these equal to y, then you can set them equal to each other. So I'm going to move this. This is, I don't know why I'm putting 5. All right, so I'm going to add this y over onto this side because it's a negative y right now, and I don't want a negative y. I just want a positive y. So this cancels. It's x equals. Why did I put a 5? I really want to put a 5. So this is y. So now it's y plus 5. And to solve for y, it's pretty easy. You subtract 5 on both sides. So I just moved this over just to get it over onto the right hand, to the left hand side. Do you see why I decided to add the y on both sides? It's because I see a negative y and I don't want to divide by a negative. I just don't. So I move it over to the right hand side, and what that does is to get the y to a positive number. And if it gets to y to a positive number or a positive variable, that makes it a little bit easier for me to solve for the positive that I need to solve for. So now do you see I subtract 5 on both sides and I get y equals x minus 5. Since this is already equal to y, now I am going to just put x squared plus 5x minus 17. And that equals x minus 5. And the reason why it is equal to each other is because they're equal to the same thing. So now I'm able to go ahead and try to get this to a trinomial that I could factor out, right? Because if I get it to a trinomial, that means that maybe I could factor it into 2 binomials. So I'm going to subtract the x over here, right? And going to add the 5 here because they're like terms. So then this becomes x squared plus 4x minus the 12. And that all equals 0. It's important that you're going to put that 0. So this is a trinomial. So what I'm going to try to do is factor it into 2 binomials. Let's see if it works though. So this is x times x because x times x is x12, x is x squared. So I'm going to put this 12 here, and I'm going to look for factors of 12 that multiply to 12 and that add or subtract to 4. So I have 3 and 4 that I could go on and look at, but I could see that I have to add or subtract to 4, and maybe 2 and 6. That could be the, those could be the factors there. Because if you subtract them, yeah, that equals 4. But you have to multiply to a negative, which means one has to be positive and one has to be negative. So which one has to be positive and which one has to be negative to multiply to a negative 12 but add to a positive 4? Well, yep, if you said positive 6 minus 2, 6 minus 2, that is, it subtracts to a 4. So that also multiplies to negative 12. So you did it. That's it. So now we go ahead and use that zero product property law, and you have x plus 6 equals 0, x minus 2 equals 0. And then we have minus 6 minus 6 and plus 2 on both sides here. And you have x equals negative 6 and x equals 2. So now you have the x's, but you need the y's. So it says all values of x and y. So we're going to talk about this, and look, I solved for y here. So I'm going to use this. This is x minus 5. So I'm just going to write this down. Y equals x minus 5. So when x is negative 6, y equals x is negative 6 minus 5. That means y equals negative 11. So this one, then I'm going to go y equals, when x is 2, 2 minus 5, y equals negative 3. So what we're going to have here is the value of x here and the value of y here. So these are the coordinates. It is negative 6, comma, negative 11, or 2, comma, negative 3. Just be careful when you write that down. It is negative 6, negative 11, or 2, negative 3. Now, if you really wanted to, you could put, do you see this right here? This is the trinomial. So if you want to check out if you're doing this correctly, you could grab your calculator and put in y equals, I'm going to move this over here, x squared plus 4x minus 12. And if you press graph, you could see right now, do you see negative 6? See, look at the x right here. Negative 6, 2. So it should be 1, 2, 3, 4, 5, 6, negative 6. And it should be 2. 1, 2. And it is. So that means you know that you have the right x's, right? You have the right zeros. So when you're solving, if the x's are wrong, if the zeros are wrong, that means the y's are going to be wrong. So you're correct. And that means you don't have to ask anyone, is this correct? You just check out the x's because you solved for those zeros, negative 6 and 2. You verified it in the calculator. The calculator verifies that it does cross at those points. So you're good to go. All right. So another difficult question that a lot of people have, trouble with is this one. All right. There's a lot. There's a high school wants to sell 850 tickets at a dance, sold tickets in advance. So the tickets sold in advance are $6. Tickets sold at the door cost $8. How many of each type of ticket will the school need to sell? And then only an algebraic solution will be accepted. So I always, if I'm looking for a system of equations and looking to see if I could solve this, I always start with the easiest thing first. It's the amount of the tickets that are being sold, not the money, but just the amount. So we have advance tickets being sold, and we also have door tickets being sold. How many tickets? They want to sell 850, so that is what we're going to set that equal to. So right now, do you see you have just the amount tickets? So now we're going to talk about the money, right? So how much did each advance ticket cost? That's 6. So you put that right below the 6x. And right next to the x, because that's how much the advance tickets cost. The door tickets, if you buy something at the door, it's $8, $2 more. And then how much did all of that profit? $6,100. And there it is. That's what it is that you have to solve. How much of each ticket did you sell? I'm going to multiply on the top. You could do this either way. You could do it substitution or you could do elimination. I am going to minus, I'm going to multiply by -6 because I want the x's to cancel. So I'm going to go over here and do -6x, multiply doing distributive property. And just remember, you have to multiply all of the terms inside the parentheses. And this is -6y. And that is negative 5,100. Now, if it does become a negative, don't worry, because do you see this 6,100? That is going to make that positive. Now, if you divide and you come out with a negative answer, you did something wrong, right? Because there are no negative tickets. So this cancels, and then you have 2y. You're adding negative 6y plus 8y, that's 2y, and negative 5,100 and positive 6,100. When you combine them, that is 1,000. It's a positive. Notice that you have all positive values here. So how many door tickets? The door tickets, 500. Now you have to solve for the amount of advance tickets that were sold. So I'm going to put down right here, x plus y equals 850. And I'm going to substitute my y in. And subtract the 500 from each side. And it looks a little sloppy. Okay. This cancels, and then you have x equals 350 advance tickets. And that is the end of what they want you to figure out. There's 500 door tickets, tickets sold at the door, and then 350 advance tickets. And that is it. All right. So number 5, state the domain and range of this function. So domain, just remember, you have the domain, so list of all x's, and range is a list of all y's. So remember x and y. So state the domain. So let's talk about the domain first. Do you see how this goes on forever in this direction? So you're talking about a negative infinity. Now, do you see how this goes on forever in that direction? That is positive infinity. That way. Now, just to check out, do you see how this 1 has an open circle? This 1 has a closed circle, so that means 1 is included. This negative 2 has an open circle, but the negative 2 is here, the closed circle. So that means every x is accounted for. So the domain is simply parenthesis, negative infinity, positive infinity. That's the domain. Now, range is something a little bit different. We're going to go to the lowest part of the graph. That lowest part of the graph is negative 4, and negative 4 is included in that because that range is because it has a closed circle. So we're going to put a bracket and negative 4. So now we have to check to see negative 2 is involved. Yes, this is all involved all the way up to 5. And then it goes further all the way this way. So it's positive infinity up here. So I'm going to put positive infinity. Remember, it's not equal. It's never equal to infinity. It is a positive infinity, and you are finished with that. Or you could write it in like this, y is greater than or equal to -4. All right, so that's interval notation, and this range is as an inequality. So now it says write the equations of the piecewise function. So we'll do one at a time. So we're going to talk about this one as being A, this line as being B, and then this as being C. I'm going to write each equation. When we write the equation, just have to be careful. Do you see how this has a -2 slope? Even though it has an arrow up, this is not a positive slope. It's negative. It goes down from left to right. So it's down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. There's the y-intercept of A. So we're going to talk about line A. Line A is y equals -2x, and it is -5. That is the M is the just remember the slope is -2. That's the reason why I put that down. Let me just move this over just so I'm not going to move that over, I guess. M equals -2 and B equals -5. And that's a piecewise function. So we are going to put, I just didn't know how to fit it on the page. So that's the best way I could do it. So this, just to remind you, the slope is -2. The y-intercept was -5. The domain of this, remember the x, -2. So its x is less than -2, not less than or equal to, because this is an open circle. So now we're going to go to B. And I'm going to put this in red, B. So line B, we have to figure out what the slope is and what the y-intercept is. And that is pretty easy because the y-intercept is given. The y-intercept is here at 2. So we're going to take a look at the rise, 1, 2, 3, and the run is 1. 1, 2, 3, and the run is 1. So we're talking about a rise of 3, 1, 2, 3, and a run of 1. So this is 3 and 1. So that means the slope is 3. And it's going up from left to right. So this is y equals 3x plus 2. And then let's see what the domain is. The domain starts at -2. We're going to talk -2, and it's equal to -2. And it does not, it ends at 1, but it's not equal to 1, so we're going to put a parenthesis. All right? Or you could write it as a compound inequality. Let me move this over as much as I could do. I could put or, and then put the x in the middle. Its x is greater than or equal to -2, or less than 1, and less than 1. All right, so you could write it either way, like that. So we're going to talk about C at this point is the last part of this. And you know what the y-intercept is? That is -2. So this is line C. And the y-intercept, so the slope is 0, because a horizontal line has a slope of 0. And the y-intercept, which is B, is -2. So you have a slope of 0 and a y-intercept of -2. It's y equals -2. And you could just put that in the calculator. Look, see, if you put y equals -2 and you graph it, it is a horizontal line. Horizontal lines have a 0 slope, and -2 is what all of the y coordinates are along that line. This is 1, -2. This is 2, -2. 3, -2. -2, just continues on forever like that. So this domain, though, it starts at 1. So we're just going to put a bracket at 1, and then it goes on forever to the right like that. Or you could put y is greater than or equal to 1. And those are the 3 lines right there. Right? So that's that. So when you have a graph like this, it is very, very easy to figure out like what the f of 1 is. Remember, this is the x. When we're talking about the x value that is inside the parentheses, you're talking about the x. So when x is 1, which, like obviously looking at the graph, what is the y? It is -2. Right? When x is 1, the y is -2. You don't go up to this one because 1 is not included in that line. It's an open circle. You could also put, all right, so when x is 1, the equation that would work according to the domain is only this one. Notice this is line C. Its y is greater than or equal to 1. And that means, I'm sorry, I shouldn't have put y. That is x. Look at that, I messed up. Remember, domain is always x. So you should not put a y at all for that. It's always x. And I'll get that right there. All right, so the x is greater than or equal to 1. When x is 1, that means the y is -2. But you have the graph, so you could go by the graph. It's nice and easy. When x is -4, what's the y? Well, there's no other line to go to but a. So when x is -4, the a is 3, so we have 3. And then when x is -2, what's the y? It's 4, -4. So, and you could just take a look. If you didn't have the graph, you could just go by the domain of what this is. Where is x is -2? It's not for line A. X is -2 is B. So that's why it's -4 there. So, but with the graph, it's just much easier to just look at where the x is, go to the line, and just tell them what the y is. And that is it. So for number 6, given the formulas are given on the reference sheet, so they give you 2 points. Write the equation of a line that's passing through the 2 points in point-slope form. So first off, you have to figure out the slope. And all of this is on the reference sheet, but like honestly, y2 minus y1 over x2 minus x1, it's not something that you should forget. Right? So I moved it down, but I don't know why. I'm just going to put x1, y1 up here and x2, y2 here. So we're going to put m equals, and very simply put the minus signs in from the formula. You're going to do 4 minus 2, that's y2 minus y1, and then 3 minus 6. When you put this into the calculator, don't even do this separately. We're just going to put it in as a, let me get this out of here. Yep. Put it in as a fraction, alpha x, and just do 4 minus 2, the numerator, and then the denominator 3 minus 6. Let the calculator give you -2 over 3. See how it's -2 over 3? Let the calculator give you that. All right. So the m, the slope, is -2 over 3. Now, just remember, you need the point, you need the y-intercept. So there's 2 ways to get the y-intercept. One way, you can go, this is like 1 and 2. you could go and use y equals mx plus b and then solve for b, or you could use the point slope formula. So I'm just going to use the point slope formula. Because it's on the reference sheet. So it's y minus y1 equals m times x minus x1. So point slope form. We're talking about this right here. This is point slope form. And actually, I'm just going to erase number 2 because they want it in point slope form and then slope intercept form. So we're going to write down that formula y minus y1 equals m times x minus x1. And then we're going to substitute those numbers in, and we're going to do y minus, we're going to put y1, which is 2, equals m. We figured out the m is negative 2 over 3. The x stays x minus x1, which is 6. This is point slope form. That's what that is. So now write the equation of line passing through the 2 points in slope intercept form. Slope intercept is y equals mx plus b. Slope intercept. So we're going to just take this and we're going to rewrite y minus 2 equals negative 2 over 3 x minus 6. And all we're going to do is distribute and then solve for y. So then we have y minus 2 equals negative 2 over 3x. And this is positive because negative times a negative is positive, and that is negative 2 times negative 6 is 12 over 3. 12 over 3 is 4. So when we have 4 right there, now we're just going to, I'm going to rewrite it up here. Y minus 2 equals negative 2 over 3 x plus 4. And guess what we have to do to solve for y? We have to add 2 to both sides. When that cancels, this cancels, you get y equals negative 2 over 3x plus 6. And that is your point slope intercept form. That is slope, has a slope in it, and it has the intercept. It says write a line, write the equation of a line that is parallel to the line in parts A and B, and that passes through, has to be parallel. Oh, nice. Has to be parallel, and it passes through 6, 7. All right, so remember, you're going to use y equals mx plus b because you have the slope that it needs to be. You're writing an equation for a line that is parallel to what you have there. So the slope is negative 2 over 3, and they give you a point, x and y. So all you're going to do is substitute the y into y equals mx plus b and the x in. And then you really just have to figure out what this is and solve for b. So when you put this in, it's negative 2 over 3 times 6. Negative 2 over 3 times 6 is negative 4. So I'm going to rewrite this. 7 equals negative 4 plus b. And then we're going to add 4 to both sides. And this is 11 equals b. So b equals 11. So the equation of that line is y equals the same slope plus 11. And that will be it. All right, for Michaela's 16th birthday, her grandmother gave her a present of $5,000. So I'm just going to highlight, gave her a present of $5,000. That's nice. Decided to put the money in the bank. It earns 6% interest per year. Write a function that represents how much money will make, that Michaela will make over time. So we have to take these numbers and write a function. Just remember, this is not a decay, right? This is not a decay. So you go to your reference sheet. You see this reference sheet right here? A equals P times 1 plus R. So we're going to just go to A equals. We're going to write that down. A equals P for principal. I put 2 equals. Times 1 plus the rate. And then N. That's the time. So it's 1 plus R. Because this is not a depreciation. It's going to increase in value. So we're going to put A equals the principal, which is 5,000. That's how much that Michaela started with. 1 plus, and then we're going to take 6%, and we're going to make it a decimal. If you move that 6, move that decimal 2 places, that is 0.01. So it's 0.06, sorry. And then N. So that's it. So now what will Michaela's balance be on her 21st birthday? All you have to do is use that formula, 5,000. And N is 21. Times the 1 plus the 0.06. And then grab your calculator and put 5,000 times the 1 plus 0.06, not 0.6, to the 21st birthday. So this is 20. Whoa, I messed up there. So 16th birthday. Almost messed up. So 16 to 21. So 21 minus 16. And that's 5. So N in 5 years, these are the mistakes that you can make. And I just realized it when I was putting it in. So I'm going to press delete there and delete one more time. And then put 5 in. And then enter. So we're talking about 5 years later. And we're going to take the A equals, we're going to round it to the nearest hundredth without them telling us, because this is money. So it's 6,691. 0.13. So this is basically a growth. If you see a decay of any time, like they're going to probably say something like a car or computer that like loses value. This does not lose value. This is a growth. So it's 1 plus instead of 1 minus. And that is your final answer there. That's how much the balance will be on the 21st birthday. Don't do like I did. I almost put 21 in for N. It is 5 years on the 16th birthday. The only way it would be 21 would be if like she received it like at birth, right? She received this money at birth. How much will it be on her 21st birthday? That's 21 years. So 5 years later, though, the N is 5 and it's 6,691. They could ask you how much money did she earn. You would just subtract 6,691 and the initial value of 5,000. All right, so we're talking about mean, which is average, range, which is max minus min, and standard deviation, right, when using your graphing calculator. So they give you a set of numbers right here, and we're going to put that directly in. You know how to put this into the list. You press Stat, Enter, and you go up to L1. You clear it out and Enter. So we're going to put 2, 3 4s, 2 5s, 1 7, 1 9. Now we're going to press Stat, go over to Calc, and we're going to press 1 var stats because we're not looking for the the linear regression of this. We're looking for the mean, right? So the mean is 5. You see the X with the line on top? That is the mean. So I'm just going to put that up here, X with the line on top. It is 5. The range is the min and the max minus the min. And the max minus the min. Let me bring the calculator back up again. The min is 2. The max is 9. So it's 9 minus 2. And that's 7. Standard deviation is right here. X equals 2. All right, sigma X equals 2. Create a dot plot for this data. So we're talking about a dot plot, and we're talking about the 5-number summary. We're like it's going from 2 to 9. So we're not going to talk about a 5-number summary at all, because that's for box plot. So we're just going to put 1 through 5, 1 through 0 through 10. And we're going to put dots above every time we see those numbers. So 2, 4, 3 times, 5 twice, 7, and 9. And that's it. All right, so for which function defined by the polynomial are the zeros of the polynomial -4 and -6. Zeros. So X intercepts. I would use the calculator for this. So we're going to just bring this out, move me over here, move this over here. We're going to press Y equals. So we're looking for -4 and -6 to be the X intercepts, the zeros. X squared minus 10X minus 24, and we're going to press graph. That is -2, and I didn't even see it come up on the other side. So this one is -2. So I put this into the calculator, and look, I see this. You see this blue one? This is -2. To see the other one, obviously this is going this way, and it's just a long a large parabola, so it comes back up off the screen. So I could press window and I could go to X max and just make it 20. And you could see now that I could see that blue where it comes back up, and then this is 12. So if that's 12, obviously that is not what they're looking for. It's -4 and -6. So we have, I put this directly into the calculator. It's the red one. So you see this is 1, 2, 3. This is -3. Oh, sorry. Let me just switch this out. You could see that I put y equals x squared plus 10x plus 24, and we have the two that we're looking for. This is -1, -2, -3, -4, and -6. So -4 and -6, what they're looking for. B is your answer. You don't have to do the rest of them. You don't have to really even worry about it, but you could do it by hand as well, because remember, every trinomial factors into two binomials. So what you're looking for, really, if you're going to take it by hand, let's just say x squared plus 10x minus 24. You're going to look for two numbers that multiply to 24 and that add to 10. So 1 times 24, no. 2 times 10, 2 times 12, that works. So we are going to use those. X, and then we're going to put 12 in and 2. So to multiply to a negative, one has to be positive, one has to be negative, and to add to a positive 10, it's 12 minus 2, and then we're going to have equals 0 here, right? So you would just break it down, x plus 12 equals 0, the zero product property law, x minus 2 equals 0, and then you would minus 12 minus 12, x equals -12, which was not what they're looking for, and x equals 2, which is not what they're looking for. So if you do this one, it does work out where it is x plus and x plus, and then they would both be negatives. We proved it in the calculator. No reason to do anything else. All right, and that ends the long spiral review. Hopefully you got a lot out of it and it helped. Any questions, just ask, and that's about it. As always, thank you for watching. See you next time.